FP3 2011 question 6. For differentiate this, we're going to rewrite the second term as x minus x squared to the power 1/2. First term we can differentiate straight from the formula booklet. It's going to be 1 over the square root of 1 minus x squared. And using the chain rule, we've got to be careful. We need to multiply by the differential of the square root of x. So that's 1/2 x to the power minus 1/2. Then differentiating our bracket, bring the power down, differentiate the bracket, and take 1 away from the bracket. So that gives us, on the first fraction, 1 over 2 root x square root of 1 minus x minus 1 minus 2x all over 2. And factorising the bracket, we're going to have the square root of x square root of 1 minus x. And now we can see that this simplifies to give 1 minus 2x all over our fraction. So that is 2x all over 2 root x square root of 1 minus x. The 2's cancel, and x divided by the square root of x is root x. So we have root x over the square root of 1 minus x. So we previously shown that when we integrate this, we get the inverse sign of the square root of x minus the square root of x upon 1 minus x, being 0 and 1/2. If we substitute that in, we have the inverse sign of the square root of 1 over 2, which would be pi over 4, minus the square root of 1/2 times 1/2, so that's minus 1/2. Take away the inverse sign of 0, which is nothing, minus the square root of 0, which is nothing. So the answer to our question is pi over 4 minus 1/2. If we split the fraction, we have the integral from 0 to 2 of 4 over 4 plus 3x squared. And I notice the denominator here means I can go and look at the formula booklet. Minus 3 times the integral from 0 to 2 of x over 4 plus 3x squared. And what I see here is I have a function and almost its differential. If that was 6, then I could divide this by 6, and now on the bottom line I have a function, and on the top I have its differential. So whenever I integrate this, I'm going to get the natural log of 4 plus 3x squared from 0 to 2. So that will be minus 1/2 the natural log of 4 plus 12, so that's 16, minus the natural log of 4. With the first fraction, we'll start by taking the 4 in front of the integral sign, and then I have 1 over 4 plus 3x squared. I need this to be 1x squared, so I'm going to divide this term by 3, this term by 3, and this term by 3. This third will go in front of the integrand. So I have 4/3 the integral from 0 to 2 of 1 over 4/3 plus x squared. And then we have our minus 1/2 the natural log of 4. This is almost tan, but the tan is the sum of two squares. So if I make my first term square root of 4 over 3 plus x squared, now still using my rules of logs, I have minus ln2. I can now see that I have 4/3 the inverse tan of x, and then I've got to multiply this by 1/a, so that will be the square root of 3/4, and I'll need to put that in front of the tan as well, square root of 3/4, which gives us 2 to the square root of 3 inverse tan of root 3 minus the inverse tan of 0. And the inverse tan of root 3 is pi/3. Finally then, we shouldn't have a third in the denominator, so I'm going to rationalise this by multiplying top and bottom by root 3. Which gives us in the end 2 root 3 pi. Root 3 times root 3 is 3, 3 times 3 is 9, minus ln 2.